Last year's Super Bowl was decided by a math problem. The Chiefs beat the 49ers in an overtime thriller, but for me, the most exciting part happened after the final whistle. In his post-game press conference, Chiefs coach Andy Reid said that he thought that 49ers coach Kyle Shanahan made a strategic math mistake. This video isn't just about football. It's about strategy and how you can use math to think through decisions. The tools we're going to use, the ones Coach Reid used, come from game theory, a branch of math you can use in your everyday life to make better decisions. As we work through Coach Reid's exact thought process, we'll get to see the tools of game theory in action in a real-world, high-stakes situation. By the end of this video, we're going to understand exactly the decision the 49ers faced. We're going to understand the math that Super Bowl champion Andy Reid used to analyze the situation. And we'll see how, if the 49ers had done things Coach Reid's way, they might be the champions instead. All that today on Wage World. I'm Nick Wage. First, let's cover what exactly happened in the game. The 49ers were ahead most of the way, but by the very last second, the Chiefs tied it up 19-19, sending the game to overtime. The 49ers won the coin flip, and that gave them the right to decide who started with the ball. They chose to take the ball themselves and managed to get a field goal for a 22-19 lead. Then it was the Chiefs' turn, and on their possession, they scored a touchdown. That ended the game 25-22, and the Chiefs were Super Bowl champions.
Wins it again.
This was the first Super Bowl with new, more complicated overtime rules, ones we'll get to soon. And after the game, Coach Reid said that based on those new rules, he disagreed with Coach Shanahan's decision to take the ball to start overtime. The Chiefs thought that the team who got the ball second was the one with the advantage. So if the Chiefs had won the toss and gotten to choose, they would have given the ball to the 49ers anyway. When the 49ers made that decision for them, they considered it a mistake, and Chiefs players were even seen celebrating.
They want the ball. They wanted it.
If we won the toss, we were going to kick off too.
They want it. They can have it.
Coach Andy Reid, with 3 Super Bowl victories, is a giant in the sport. He's also literally a giant. Here he is at 13 years old, playing punt, pass, and kick with other 13-year-olds. That doesn't have anything to do with anything. I just think it's hilarious, so I wanted to work it in. Today, we're here to talk about Coach Reid's freakish ability to make good strategic decisions. So what was he thinking here? Was he right, or was Coach Shanahan right? Do you want to get the ball first or second in overtime? The answer is, it's complicated. That's why 2 Super Bowl head coaches disagreed. But we'll start by analyzing some simpler situations and slowly build up the tools to analyze this situation. We won't get all the way to the bottom of it. You could spend weeks on this problem, but we will have a good understanding of the key strategic factors that go into the decision. The best place to start is probably with the old NFL overtime rules. Up through 2010, the rules were pretty simple. First score wins. As soon as either team gets any points, the game is over, and that team wins. This rule works pretty well in a game like soccer or hockey, where possession is more fluid. But it's pretty easy to see why people didn't like these rules for football. Going first is a huge advantage. Teams would regularly kick a field goal on the first possession and win without the other team even getting a chance to touch the ball.
And Seattle has done it.
And that's actually what happened in this game. Remember, the 49ers got a field goal on the first possession of overtime. And under these rules, they would have won then and there. So it's pretty clear that under these rules, you want to go first. In fact, during this period of the NFL's history, the team that started with the ball won about 60% of games. That's a big advantage. Let's bank that number. It will be useful later. Bottom line, the overtime coin flip was really important, and it didn't seem fair. So how did they change things? Well, for a few years, they tried to fix this with a more complicated rule involving field goals. That rule isn't really worth getting into. It was confusing and also didn't really solve the problem. So starting last year, they came up with a better rule. Now, both teams are guaranteed at least one possession. By the end of those first 2 possessions, one by each team, if one of the teams is ahead, they win. If the game is tied, the ball goes back to the team that went first, and play continues under the original overtime rules. Any score wins the game.
Hey, even if we score a touchdown, they still get the ball. I didn't know that.
Let's start trying to mock this out. There are 3 outcomes from a football possession. The team can get no points, they can kick a field goal for 3 points, or they can get a touchdown for 7 points. Now, I know what you're thinking. That's wrong. They could get a safety for 2 points. They could miss the extra point and only get 6 points, or whatever. So actually, before we get into the modeling, let's get this out of the way. What I said about possessions only having 3 outcomes isn't wrong. It's simplified. Football The world, any decision, is infinitely complex. But if we worry about all those details right from the start, we'll be completely lost. We want to start with the simplest version of the problem, one we can reason about and solve. Then we can slowly add in details to make the problem more complex and more realistic. So we'll start here with this obviously wrong model and build. By the end of the video, we still won't be done. The model will still be very simplified. For example, we aren't going to talk about safeties. They just don't happen very often, and you can't exactly strategically plan for them. They just don't affect this problem that much. But we will have added in my opinion, all the most important strategic factors. I'll have a link to a Google Sheet with the model in the description. So if you want, after the video, you can play with it and add in your own details. In the meantime, if you see something wrong with the model, you're probably right. But sit tight. Hopefully we'll fix it by the end of the video. And if not, you can play with the model and try to add it in on your own. All right, back to the modeling. Like I said, a possession can end in 0 points, 3 points, or 7 points. And each team is guaranteed 1 possession. So let's make a chart of the outcome of each team's possession. We'll list the 49ers outcomes from top to bottom, and Chiefs outcomes from left to right, creating a grid. If the Chiefs are ahead at the end, they win. So let's color those cells in red. If the 49ers are ahead, they win. So let's color those in gold. Annoyingly, both teams are basically red and yellow, but we'll use red for the Chiefs and gold for the 49ers. What happens on the diagonal when they are tied? Well, there's a whole nother possession and a whole new set of branching possibilities to consider. But actually, we can simplify things a bit. After the first 2 possessions, it's sudden death. It's just like the old overtime rules, the ones we just talked about. And we know the first team typically wins those games with 60% probability. So instead of thinking about that whole branching structure, we can just plug that number in, coloring these cells 60% gold and 40% red to represent the likely outcomes in this case. We now have a visual representation of the probabilities. If more than half of this grid is colored gold, it's better to go first. And if more than half is red, it's better to go second. And as it is, it's pretty clear gold has the advantage. This is the argument for why it's better to go first. Even though both teams get 1 possession, the first team still has an advantage when they tie and it goes to a 3rd possession. But Coach Andy Reid disagrees. So clearly this picture is oversimplified. What are we missing? One problem with the model is that we aren't equally likely to get each of 0, 3, and 7 points. Remember, we're using the area of each region to represent its probability. Outcomes that are more likely are more important and should take up more space on our diagram. As we've drawn it, we've asserted that each of the 3 outcomes is equally likely and equally important. But looking at data from real drives, that isn't at all the case. After some quick research, here are my best guesses for a typical possession. The most likely outcome on a typical drive is the team scores no points. And now, that region of our diagram is much bigger to reflect that fact. This makes our model much more realistic. Remember, the areas are supposed to represent the probabilities. We can see who is favored by comparing the area of the red region to the area of the gold region. But even with that adjustment, this picture still makes it look obviously better to go first. So we still don't have a good story for what Coach Andy Reid is thinking. Now, you could disagree with those probabilities. The 49ers and Chiefs probably each have their own probability estimates here and everywhere throughout this analysis. Those estimates are probably better than mine, and they probably differ from each other. You can play with the sheet in the description if you want to put your own probabilities in. In theory, using different probabilities could explain why the 2 coaches came to different conclusions, but not with our current model. This picture will always suggest that the 49ers have a clear advantage. No matter how the probabilities move around, they'll control 50% of this box plus a little more. So what is Coach Andy Reid thinking? Why might going second be an advantage? You probably have an intuitive sense for what's going on here. The second team gets to see what the first team did and change their strategy in response to it. If the first team gets a touchdown, the second team knows they need to play aggressive and go for their own touchdown. Whereas if the first team gets no points, the second team can play conservative, knowing all they need to win is a field goal. Incidentally, college overtime has different rules. There, possessions always happen in pairs, so there is no first mover advantage. The only effect is this information advantage, and as a result, everyone chooses to go second in college. And with that, we have all the core insights we need to tackle the new NFL overtime rules. We understand the benefits of going first under the old sudden death rules, and the benefits of going second under the college rules. But the new NFL rules are a mix of these two, meaning both sides have their own advantage, making the decision much harder. If the game is going to end in the first 2 possessions, the second team's information advantage gives them the edge. But if the game goes to a 3rd possession, then the first team's first mover advantage gives them the edge. But which advantage is more important? When we factor everything in, which side will be favored? This is where our diagram will be helpful. The diagram, as is, already does a pretty good job of capturing the first mover advantage. On the diagonal, when the game is tied after 2 possessions, the 49ers start with the ball, and they are 60% to win. That's their advantage. But the diagram doesn't yet represent the Chiefs' information advantage from going second. What is it missing? Well, it starts with this box. 49ers win 7-3. This means the Niners went down the field and scored a touchdown. Then, when the Chiefs got the ball, they stalled out and decided to kick a field goal on 4th down. This would obviously never happen. It immediately loses them the game. Instead, they would go for it. So this box actually has 0 probability. Where does the probability go? Well, when they would ordinarily kick a field goal, they go for it and ended up with either 0 or 7 points. So both those boxes get bigger. The 7-7 box, where the Chiefs have some chance of winning, has been expanded at the expense of the 7-3 box, where the Chiefs had no chance of winning. This increases the amount of the total area that is colored red, which makes sense. We found a way for the Chiefs to improve their strategy, and therefore to increase their probability of winning. And that increased probability shows up on our diagram as a bigger red area. Importantly, the same is not true of the 3-7 box. It is totally reasonable for the 49ers to kick a field goal in this situation. In fact, this is the box that the actual game ended up in. They didn't know the Chiefs would score a touchdown. If they had gone second and seen the Chiefs touchdown, they never would have kicked that field goal. They would have gone for the touchdown. They might have gotten it, and they might have gone on to win. In that world, the 49ers might be the Super Bowl champions. So now we see the pros of going second, and they aren't just theoretical. This situation actually came up in this game. Visually, the representation here is that all the rows have to have the same width all the way through. The 49ers go first, so they can't behave differently based on how the Chiefs' possession goes. But the Chiefs can change the width of the columns depending on the situation. They can't change them however they want. They can't just guarantee they score a touchdown. But there is a range of choices. The primary axis they have control over is how aggressive or conservative they are. Basically, they can move probability from the middle 3-point case to the extreme 0-7 cases. In the case where the Niners get a touchdown, the Chiefs should be maximally aggressive. They should have no chance of getting a field goal. There's another way they can be more aggressive, one that actually came up in this Super Bowl. Let's look at the 49ers field goal row. Remember, that's what happened in this game. And in the game, after the Chiefs got the ball, on their first 3 plays, they only managed to get 9 yards, leaving them with 4th and 1 in their own territory. On a typical drive, teams would punt in this situation. But here, punting is an immediate loss. They should always go for it. They did, they converted, and they got a touchdown to win the game. Arguably, if the roles were reversed, if the Chiefs went first, they would have stalled here and punted. Then, when the 49ers went, they would have gotten their field goal, and they would be the Super Bowl champions. I mean, what if hypotheticals are complicated, and you shouldn't really judge decisions based on what happened or could have happened in any particular game? We should judge decisions based on the overall analysis we're doing here. Still, it's an interesting thought. Punts are the main reason why 0 points is so likely on a typical possession. By being more aggressive here, the Chiefs can move probability from the 0-point case to the 3- and 7-point cases. And remember, this actually came up in the game. They can also do the same thing when they are down 7, so we should probably shift the probabilities in that case some too, to count for this effect. Now, our diagram doesn't really show the downside of this trade-off. It sort of makes it look like a strictly good decision. But that's just because our diagram isn't fully descriptive. It doesn't differentiate between the opponent field position on a punt versus a turnover on downs. This downside doesn't matter for the Chiefs. If they don't score, they lose either way. But it does matter to the 49ers, which is why the 49ers are likely to play a more typical strategy with a high probability of punting and getting 0 points. Of course, the 49ers can also control how aggressive they are. The decision of exactly how aggressive they should be is complex and subtle, and beyond the scope of this video. But the main point is that they can't be as strategic about it because they don't know what the Chiefs will do, so they can't vary their aggressiveness situationally. The rows need to be the same width all the way through, And that's what gives the Chiefs an advantage. The last row to look at is the one where the 49ers don't score. There isn't a ton for the Chiefs to change about their strategy here, but there's maybe a bit. Here, they don't care whether they get a touchdown or a field goal. Both win them the game. So they can play a bit more conservative, but it's not a big effect. Now we've really quantified the pros and cons of each side. When the game is decided in the first 2 possessions, the Chiefs are favored. They got to see what the 49ers did and respond to it. But if at the end of those 2 possessions, the game is tied, then the game goes to sudden death, and since the 49ers start with the ball, they now have the advantage. So overall, who's favored? Well, the math is complicated, but remember, the way we've designed this diagram, the area of each region represents its probability. So all we have to do is measure the area of the gold region versus the area of the red region to see which is bigger. It depends a ton on the exact probabilities you use. But with the probabilities we've chosen, we get that the 49ers have a 50.4% chance of winning. They still have an advantage. But Andy Reid's strategic logic isn't done yet. He still has one more trick up his sleeve. It has to do with this 7-7 box. Coach Reid would never let it get to this situation. Why not? Well, here's Taylor Swift's boyfriend discussing it with his brother, Jason Kelce, on their podcast.
Even if they score a touchdown, you know you get the opportunity to, okay, now, hey, boys, now we got to suit up and score a touchdown.
4-down territory everywhere.
And you go for 2 because you don't want them to have the chance to end the game with a field goal. So it's not going to go down to 3 possessions.
Did you catch that? If both teams score a touchdown and overtime is tied 7-7, the ball will go back to the 49ers, and the Chiefs will only have a 40% chance of winning in sudden death. But Coach Reid has another option. Go for 2. Instead of kicking the extra point and tying it up, he can go for 2 and either win or lose the game then and there. Going for 2 is about 50-50, so we'd much rather take those odds than the 40-60 odds he has from playing it safe and going for the tie. Coach Reid won't let the game get tied 7-7. Remember, the entire advantage the 49ers have comes from their advantage on those 3 diagonal boxes. By equalizing part of it, he's taken away some of that advantage. Redoing the math, this brings the 49ers win probability from 50.4% to 49.7%. And the Chiefs are now, just barely, Super Bowl favorites by going second. So that's what Coach Andy Reid was thinking. And as it turned out, it worked well for him. In a way, this one decision really did decide the Super Bowl. If Coach Shanahan had made the opposite decision, and if both teams' possessions went similarly to how they went in the game, but in the reverse order, the 49ers would be Super Bowl champions. The Chiefs would have punted on 4th down, and the 49ers would have won with their field goal. Even if the Chiefs had been aggressive and gotten the touchdown, the 49ers would still have a chance. They wouldn't have settled for a field goal. They would have gone for a touchdown and also the 2-point conversion, and they still would have had a real shot at winning the game. Now, that's not quite the right way to look at this. Going second mattered a lot here because both teams were scoring. But in the world where neither team scored on their first possession, that's the single most likely outcome, according to the data. Coach Shanahan would have looked smart because he got the ball third.
The thing was we knew both teams were going to get the ball at least once, so we wanted to make sure if we won the toss, we wanted to be the team who got it the 3rd time.
One takeaway from all this is that the new overtime rule is really good. Each side has its own advantages, leading to tons of super interesting strategy and analysis. But also, in the end, it's super close to 50-50. Even NFL head coaches can't agree which side is favored. That means, unlike sudden death or college rules, the coin flip doesn't have a huge impact on the game. The game gets decided on the field by the players, but also off the field by the strategies formulated by the coaches and the analysts. The coin stays out of it, and that's the way it should be. Both teams have analytics departments, and presumably they both spent days modeling this out with all the details we left out. They would have accounted for missed extra points and field position, and yes, even safeties. It's a really close call, and it's hard to say who was right without seeing their exact analysis. But now we understand what that analysis looked like. There wasn't any magic. It looked like this, just with more details. With enough effort, we could keep refining this model until eventually we had something as good as what Coach Andy Reid has. Remember, there's a link to the model in the description if you want to give it a go. Or you can use these same simple tools to analyze your own decisions, ones that come up in your everyday life. That's the power of game theory. I'm Nick Wage, and you're watching Wage World.